So the recording has started and Augmented Cities workshop is about to start. So Vladimir Fnarovsky from Augmented City is going to start his presentation now.
Hello, hi everybody. Let's start our session. Okay, hope you can see my screen. Everything is fine. So first, a few words about myself and what we will be talking about. My name is Vladimir, and I am a co-founder of Augmented City. It's an Italian startup that is dedicated to air cloud specifically. I am in IT from 1994 and since 2006 working with computer vision tasks, starting from autonomous vehicles, all kind of AI things. But in 2016, we started to work with AR and with a big world of AR. And here in my presentation, I'll start with some basics about Air Cloud for those who don't know what it is. Then we will continue to more technical details and demonstrations and ideas of what could be done using our technology. So first of all, everybody knows about augmented reality, but not everybody knows that there are different kinds of augmented reality. Well, historically, the simplest one, the oldest augmented reality was like this. When you take your smartphone and it tries to add something, some layer of virtuality over some real image. It's local AR. It's local in terms of it's only on your smartphone. And when you switch off your smartphone, you just it's not there anymore. No one can see it. Only you once the session leaves. Then there is another kind of augmented reality. It is QR code based. When you look at some QR code, you can see some virtual object instead of that QR code. It's also quite historical version of AR, and it's quite simple to implement. But now we will be talking about most difficult, most interesting kind of augmented reality. It is persistent and shared augmented reality. This means that virtual objects can be seen by any person who is looking at some point in the world. And virtual objects are there forever. So they do not disappear. You can change your device, you can change your viewpoint, but it's still there. And several people can look at the same point and see the same object. How such augmented reality can be done? There is a big task, there is a big problem to solve to implement such kind of augmented reality. It is called localization, because if you want to see something persistently on very exact place, you need very precise localization in terms that your phone should understand very precisely what you are looking at, what is the orientation of your camera, what is your position, and it's best to be as much precise as possible. For example, take the well-known Pokemon Go game. It is a GPS-based, it has GPS-based localization, so it more or less precisely reports to the game where you are now. But the precision can be extremely bad. So if there are, for example, some narrow streets and high buildings, the localization can be with precision worse than 50 meters or even worse. And it does not really give you any precise orientation of your phone. You always need to somehow calibrate sensors of the phone to give you more or less precision angle at what you're looking at. So this GPS-based localization is absolutely inappropriate for good, persistent, and shared augmented reality. So the solution is visual positioning. Visual positioning is the possibility of your device to understand exactly its precision and orientation, processing the video feed from its camera. For example, with augmented city technology, it is enough to have one frame from your smartphone or smart glasses or tablet to be processed. And by this one frame, you can already get your precise position and your precise orientation. How it is done generally? To make this possible, you need this so-called AR cloud. AR cloud actually is a set of point clouds. It's a number of digital twins. And in our case, for augmented city, it's digital twins of the whole city and in future, I believe, of the whole world. So you have reality, you do the scanning, so-called scanning mapping. Julia will tell a little later about it. And you get the big point cloud, millions and billions of points with their precise positions. And having such point cloud, you can find those specific points once again when localizing. And thus you can add a lot of virtual objects, bind them to some positions in the real world, and they will be in this air cloud forever. Yeah, but that big question is how to create such point clouds. Originally, there were attempts to make such clouds using quite expensive devices, LiDARs, etc. But now, thanks to the technology, it is possible to do such mapping, to create such digital twins just with your smartphones. So we at Augmented City created such technology. So it is possible to create digital twins using your smartphone, any model, and store this point cloud on server. As they are stored on server, there is no real limit for point cloud. So you can add a lot of locations, and they are not stored on your phone. So you are not limited by the phone memory. Even more, different point clouds from different authors will be automatically merged if they have some intersecting parts. And once some location is on the server, it is possible to localize on this location, regardless of whether this digital twin was created by you or by somebody else. So once the point cloud is there, you can localize in that position with very high precision. It's like 10, 30 centimeters of general location precision, and much less than 1 degree of angle orientation precision. Our technology works in every lighting and weather conditions, very robust. Well, this is proven by already millions of tests all over the world. And localization itself is very fast. It is done on the server, and actually it takes much more time to send the image taken by your camera to the server, then to localize this image and return the geopose of that image. Well, and once this geopose is retrieved from the server, you can use Unity or some native application just to track position using ArcoArKit or Unity. We, as Augmented City, offer the free open source applications, sample applications to do exactly this. Well, it's better one time to see than 1,000 times to hear. So that's let's move to more funny part and show some examples. One second, let me switch to the videos. That's how it works. So we have a big square. It's about 1 kilometer by 1 kilometer square. We create the digital twin of it and added a lot of virtual objects there. Now you can fly all over this square and see everything as if it is real. You can create virtual portals. It's a door to another dimension, to another reality. You can enter this door, enter this room. You can interact with virtual objects, and you still can see the reality. You can still see other virtual objects out there. So even through the window, you can see both virtual objects and real objects. The dock is virtual. And I'm proud to show the application just released by our partner NovaBuy. Julia will be present in it. And it's a virtual Blackhawk, virtual jazz bar, right on its historical place. You also can enter it.
Sorry, we still need to edit.
Yeah, so you can see you can do a lot of wonderful things using the AR and persistent AR, and the best thing out here is that your experience will be shared. So if you have your friend together with you, he can use his own smartphone to see exactly the same. And then you will be working together in this bar, seeing the same environment. Mm-hmm. Okay, so now I'd like to pass the word to Julia, and she will tell how to actually do the mapping, how to create the digital twin using your smartphone.
Can you hear me okay now?
Yes.
Okay, great. I'll try that again there. Okay, yeah, so as I said, my name is Julia. I'm with Novabuy. I'm the CEO and creative director. And we are kind of in contrast to a lot of other companies that started kind of with the selfie types of AR, as Vlad talked about, and moving to the outdoor. I come from a background of building design and construction, so we just went outside right away. So we've been kind of coming back in the other direction and really working in outdoor world scale persistence AR for several years now. And it is kind of a different world out there, but the things you can do, as you can see, are pretty amazing and incredible. And we find them really fun and exciting. We're particularly working in kind of these historical, kind of cultural heritage types of works and public art also. So anyway, so as Vlad mentioned, the Augmented City is actually a suite. Let me try getting into present mode here. Augmented City is actually a suite of tools that enable you to get to the point that Vlad was just showing you on the videos there. So obviously you start with an idea, you see a cool place, you want to put some digital objects in there or enhance it. And so the first thing you have to do is scan that space to create one of the point clouds that Vlad showed you. After that, and that's what I'm going to be talking about, after that, you then use their next tool to place objects in the site. And I believe Ali is going to be talking about that. And then ultimately those get used in either Augmented Cities application, which is kind of a viewer of these things, or you can create custom applications in Unity or ARKit or ARCore, any of the native applications to create more interactions and a independent, freestanding, standalone experience. So, so as I said, I'm going to be talking about how to scan the spaces that you want to use. This is one of those things that's actually a lot easier to do than it is to explain. So I've got quite a number of slides here, but it's actually a pretty quick, easy process. It uses your own mobile phone. It takes a little practice, I will say that, to learn. And so that's what I want to share with you today, just kind of some lessons learned, tips on how to get a good scan. But it's very doable, and it usually just takes kind of 1 or 2 times before you get it and develop the right habits. That's really what it's about, is developing the right habits. So I'm just going to walk you through an example that actually everybody on the phone here, a project everybody on the call worked on, and how I approached scanning for this. So this is a project called the AIDS Memorial Pathway Project. It's a mix of culture, history, art, public art project based in Seattle, and is just opened this summer. And so it's spread out over a 2-block area. So it was quite a big area that we needed, and the customer wanted to have scanned and used for the experience. So here's kind of the architectural rendering of the space, which is great for giving you a sense of the scale and scope of this kind of mid part of the project. And then here is the physical. This was still kind of in progress. You can see our beautiful Seattle days there, but you can see there's public art here. There's another big piece here. We had some buildings. So this is actually a very good scannable space, and we'll be talking about why. So what we're creating is what's called a sparse point cloud. And so if I've looked at this enough that I can immediately tell what's what in this scan. But for those of you that are new to it, you can see kind of the real world elements here that I've put on each of the sides to give you a sense of what you're looking at there. And so this is ultimately what you're going to be seeing in terms of your interaction through Augmented City's website once the scan is created. And I just want to talk to you some about the terms that are used, because I think that can be the most challenging or confusing part. A lot of the way these terms are being used, they're like normal words, but we're not using them in normal ways. So basically the first concept you need to realize is a location. And a location, like this whole area, would be considered a location. So it's usually a large collection of points that you have scanned. Then within that location, you have passages, and passages are a subset of collection of points that you've scanned. So this would say be a passage here. And that's really just to help you divide up your work. It's really not for the computer, it's really for you, so that you can track your work, make sure it's saved in certain increments, and that you're not losing your work along the way. And then each passage is made up of points. And so any one of these dots is considered a point. And there are minimum numbers of data points within those. So for points, you need a minimum of two pictures, basically. And then for a passage, you need a minimum of 2 points. And then the really important element that I really did not appreciate when I first started doing this and made this mistake repeatedly is that you have to calibrate your phone before you start scanning a spot. And the important thing to realize there is that the calibration part of the exercise is really just to take your phone's native kind of, in a sense, measurement system and relate that to Augmented City system. That is its only purpose. It really has nothing to do with what you're scanning. And so that's a really important point to remember. Okay, so again, just kind of a calibration scan here. Important thing to remember, as said, is that it's really not related to what you're scanning. So in this instance, I used actually an area over here that it was not necessarily related to what I wanted to scan, but it was a great area for calibrating. And so when you calibrate, it's going to be a flat, straight scan, generally about 10 feet away from you, and you want to get some high contrast. You could even scan at home on a good surface that meets those qualifications before you get to your site. So basically, you're trying to get your phone to understand what 10 feet is. And how that relates to Augmented City's measurement system. And then you're going to start scanning your points. And we'll talk about that a bit more. And then you're going to do multiple points and to create a passage. So this is a passage in this instance. And then finally, you're going to do another passage. It's usually you're going to need more than one for most sites, but it can vary. And so then I'm going to walk you through a little bit of the physicality of what you were just seeing kind of digitally there. So once again, here's the plaza space, and we'll just walk through how I scanned it. So here's where I did the calibration point or area. So again, just walking in a straight area, you can see this had a lot of kind of contrasting imagery on it. Low reflections, you want to stay away from like glass is difficult for the computer vision to read. So that just basically walked by for about 10 feet, and their system will tell you when you have enough pictures that you're calibrated. And that's basically what's happening is the phone is just taking a series of pictures that's then merging into a point cloud. Then for the first point, basically, there's a few different modes they have, pro mode, auto mode, there's linear mode, there's circular mode. I find that most of the time I need to use the circular mode. I find it the easiest to use. And so you're going to stand there basically and turn in a circle, and you're going to take, you're going to be snapping the pictures as you go around. And that's what their software does, is merge that together. And then you're going to do a minimum of 10, preferably 20. You can even do more. And I tend to do more if you want a really kind of dense, high quality scan. The key things to remember here is you don't want to spin too fast, because that can make the pictures blurry, which is then hard for them to manage on their side. And you want to keep the base of your phone, so the kind of the bottom of your phone screen of what you're viewing, pretty much at the horizon of the vertical and horizontal planes. So you're basically trying to capture the vertical plane. And so to do that, you're usually going to be pointing your phone slightly upward to avoid getting too much ground. The other thing to realize, which again took me a while to appreciate, is that your phone is actually capturing a lot more vertical or your camera is actually capturing a lot more vertical and horizontal area than you are seeing on the screen. So you could do multiple scans to get the higher areas, but reality is you probably don't have to, because by the time you do the area, your phone will have captured it all because of that larger area that it's doing. And then you're going to do multiple points. There's guidelines within their application in their help section that tells you kind of how far you should move for each point. For me, I tend to just do 6 feet. I find that that works well, or 2 meters works well for me. And then you're going to do another passage. And again, the passages are really for you. So your work will not be fully saved until you complete a passage. Okay, and so here's their UI and just a few tips while we're here. So this is actually the room I'm sitting in right now. So you can do this indoors or out. I did 3 passages, and you can see here it tells you the number of pictures that you're taking, and that's the thing to keep in mind, is it's not actually video you're taking. And then they also have different modes that you can do it in. It's daylight, kind of sunset, and at night. I find that most of the time I just need the daytime mode. So you don't have to do all the different modes. And then what you're going to do here is, once you take all of these pictures, you're going to be uploading them to their server and letting the server do its work in terms of processing all of the images. As it's uploading, it will tell you, what percentage you're at there in terms of successful uploading. When you're successful, it'll tell you, this will change to say processing. Depending how big your scan is, or basically how many pictures you have in your scan, it can take a while, but it's really gotten pretty fast at this point. The maximum number of recommended pictures that you take within a given location is 2,000. You technically could go over that, but I definitely do not recommend it. In my experience, it's taken a lot longer for the server to process more than 2,000 pictures within a location. And then this percentage here tells you your success rate, meaning how many of the pictures basically were readable for the computer. And you want to make sure you have a success rate over 75, so 75%. So if you're less than that, you will want to rescan the area. And then you've got an ID here, and you can then go to their admin tool and actually see your point cloud. I put these here so you could compare. This is actually the scan itself. And you can see, you can really tell what the area is. And then what they're doing is they're extracting or reducing the density of that cloud to make something that's faster and easier to use. So that is kind of scanning in a nutshell. They've got a great help menu in the bottom left corner here. And so there's a lot of good information there. So that is scanning. I will turn it back over. I think, is Ali going, or Vlad's coming back up? I'll let you guys jump in.
Yeah, it's me. Thank you, Julia, for explanation of scanning. And now let's see how the scanning actually looks like on a server. So let me show my screen. Yeah. Here you can see so-called admin tool, and this is a world map that contains all the digital twins that are already there. Currently, it's about 150 cities worldwide. Well, some of the cities are quite well mapped. Some of them have only some parts of it mapped. So when you do the mapping, you can see it in the admin tool. This is Taksim Square of Istanbul. You can see the point cloud overlaying the map geometry. Also, you can see just points where points where the frames were taken. So this was the path of mapping. So here we can see a small calibration scan, and these are all normal scans. So this point cloud is quite big. Point clouds can be both external and internal. So this is example of outdoors point cloud, but here, for example, another example in St. Petersburg, we have point cloud of indoors point cloud. This is a part of Hermitage. It's right there. It's a throne room where old Russian Tsars were sitting. You can see point clouds right here, or in a separate view. You can always download them. You can download sparse point clouds or dense point clouds, or create a full reconstruction. So this admin tool is actually quite powerful because you can not only see and check your reconstructions here, your digital twins, but you can also see the objects you are adding here. For example, in this room, we added a number of different objects, most of them just 3D objects that are persistent and shared. You can create object right here in admin tool. So yeah, sure, you have the possibility to add the object on spot when you are looking on your when you are staying on the location and look into the place where you are where you want to add the object. But you also can object here, just using this button. And later you can manage this object, so you can delete them, you can transform them, check them, etc., etc. And also admin tool is very important for you to work with your Unity application, because when you make your application, sometimes you want to interact with these objects, and to do this you need to add different properties. You can add different properties to this object. Like for any object, you can add a link that will be retrieved by your Unity application, and from that link you can download some additional data. Well, and if you're curious about how the fully mapped city looks like, it's this. So it's a city of Bari. It's about 100 square kilometers of streets, fully mapped. So we have a very big 3D digital twin of the city. So as you can see, there is absolutely no limit to the size of point cloud, and to start localization, to show objects virtual objects where they should stay, you do not need to download this point cloud to your phone. You just send one image to our server, and it returns the exact position of your camera, the orientation of your camera, and also all virtual objects that can be seen here. For example, in the city of Bari, there are a lot of them, like 5,000 virtual objects here. There are virtual objects for every shop, for restaurant, etc., etc. So just working by the streets of Bari, you can get information on any shop or any restaurant and click on its marker. And for example, for restaurant, you will be forwarded to its TripAdvisor page. That is quite convenient. Okay, so this is about admin tool, and now I'd like to give the word to Michela. And Michela will show you how to download the open source sample application, compile it, and how to start working with it. Thanks, Michela.
Yes, I'm here. I'm going to share my screen. You can see my screen? Okay. You can download the source code of the AC Viewer. That is our application to see every kind of object in the scanned area, always using our tool. Anyway, you can find this repository, open repository, also visiting our website. You can see our page link. I hope yes. And I'm going to show you how downloaded source code and also how to get our application and play with this. This is our Unity project. I hope to the important is ensure this. You have installed special packages here in Package Manager that you find in Windows. You can install AR Foundation and also ARKit AR Core packages. You can see my screen or only.
Yeah, Michela, we can see only.
Okay, I probably yes.
Yeah, you should share the whole screen.
Mm-hmm. You can see now everything.
Now it's better. Thanks.
Yeah. Now
perfect.
Yeah.
Perfect. I'm showing you. This is our website, and exactly here you can find the link to our GitHub, our repository. This is the repository, and you can find all requirements in order to prepare the software environment and play with our Unity project. Okay, this is the demo scene, and here, clicking here, Windows and Package Manager. you can install all necessary dependencies. In our case, we are using AR Foundation, AR Core, and ARKit XR plugin that are basically, these are the module, the packaging that you need to start with our application. You can find the scene exactly here in this folder, Augmented City, Scenes, and Aug City Demo. You can start with this. And of course, you can build this project for example, I suggest to you to start with PC application. You have just choose this architecture and start to build the scene. Of course, take a little time. I would like to show you this tutorial that I think is very useful to start. Described all the preliminary steps and how all dependencies that you install. Of course, I suggest to use the GitHub Unity Hub because this is a standalone application that you use to manage several versions. The minimal version is this, but you can find found everything here. This is the minimum, but of course you can use switch to higher version of Unity. And also in the README of our source code, there are the version, the old version. We have to update this. And of course you can use other version like this. .0x. You can choose, of course, other version. You can see several versions. You can even use the latest version of AR Foundation, the same for AR Core and ARKit. Using Unity Hub, also you can install easily each module, just clicking to these 3 dots here and add every module that you need. For example, to build for iOS platform or to build for Android. And in this case, other dependencies that you need are Android SDK and NDK tools or OpenJDK framework. We come back and I would show you how build, for example, for Android, but probably, okay, in builds, we can select this folder and build for PC. Okay. The important is looking here, player settings. What is important here? It's important other setting. You have remove Vulkanian from here. Put this to true this unsafe code. This is very important. And removing is just removing, so you cannot see Vulcanian here. Okay. Anyway, also in this tutorial, I put several screenshots. This is, for example, the part where updated, where are the updated packages with the updated version. Unsafe code. I would want to, we can also switch the platform easily. Just the time to do this, to perform this. Okay. Sorry, it takes a bit time. Okay, you can choose also build a folder, test, in order to produce the APK. Everything, of course, are installed to build for this platform, for Android. And just about a few seconds in order to create the APK. The same will be for iOS platform. Of course, in case of problem in console part, you can see everything, error of compilation, building, and so on. This part is not so nice with the previous. It's a very technical part, but this part could be interesting for developers, probably. Anyway, in this way, you can create a software environment easily. I just downloaded our source code, everything okay. Test. Of course, I created previously another APK, and just copying this APK in our smartphone, Android smartphone, you can use it immediately in order to see every object. But you can also run the scene, okay, this way. In this repository, you can also find some models like this. You can put it in the scene, and also moving it. Oops. Okay. Will be appear here. You can see also in game view. And how can you perform? You can create every kind of scene. Also, you can create a prefab. I created this before. I can show you my scene. You can also run the scene, and also you can create a prefab. I created this before. I can show you my scene. 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 I can show Here, there is our tower. And the benefit of this application is this: you can create also a bundle asset, and you can, of course, download every kind of object with animation and so on in runtime. It's enough just create in this way, including our model in empty object, renamed OBJ. And in this case, you can assign a name here. You can, for example, create new bundle, for example. Oops. Okay, new. And you have only build in this way for Windows, Android, yes, suggest to use Android. In this way, you will able to create the bundle for this object or complex scene as you want. You can build for Android and iOS, and we can put this bundle in our system. And how can see in you can see use our AC viewer to see this created new object in the scanned area. That's all.
Thank you very much. And Michaela, I would like to thank Julia and Vladimir as well. Now, I just would like to connect today's session with tomorrow's OpenAI Cloud workshop. What I will be doing there tomorrow is, let me take up one slide here and talk about where Julia referred to me. There is a slide that Julia had here, and I just would like to let everyone know that tomorrow what I will be talking about would be how to upload the content to the web and how you can use XRMaster's browser to place your content onto your space. And after that, as Julia stated, there are several apps, and one of the apps that you will download for placement is XRMaster's app. You can test your results using our XRMaster's app, and as well as AC Tourist app. Tomorrow we will have a session talking about how to upload and how to place those content. And the connection between OpenAI Cloud, which is one of the organizers of this challenge with Augmented World Expo and Resite, OpenAI Cloud Association, OARC, drives the development of an open spatial computing platform. And the team at OpenAI Cloud has created reference implementations of the core pieces of a platform towards interoperable spatial computing technology, data, and standards to connect the physical and digital worlds for the benefit of all. So OpenAI Cloud and Augmented City works very closely, and I'm proudly announcing that Augmented City is the first open spatial computing platform compliant company providing localization services along with all this ecosystem that you're seeing. And as XRMasters, we're proudly the first company to provide OpenAI Cloud OSCP compliant browser that you will be learning about tomorrow. So that's the end of the session for today. And I'm checking if there are any questions that we had on the chat, and I don't. So there are a few questions that are not answered. Susan has asked how much larger are the calibration steps clearly identified in app? What formats are the downloads? So this is a question for how much larger are the calibration steps clearly identified in app? We're talking about scanning.
Those are actually two separate questions. Sorry.
Sorry, yes.
So Julie was saying that the camera takes in more than what you see, and I wanted to know how much more, like 10%, 50%, just to get an idea on how much more it takes in.
Yeah, so I think that's a good question. I don't have a numerical response to that. Vlad might have a better numerical response in terms of percentage. I think there's two things to realize. One is, it does see more than, I feel like actually when I take a picture, when I'm using it, it's probably something like this, right? That's not a very not very scientific or precise answer. I don't know, maybe Michaela, do you know?
Yes. The calibration is a linear scanning, of course. There are no particular steps, but probably it's a question there are 20 frames, the minimum number of picture that you have to take, moving slowly or moving not so slowly. The calibration is a linear scanning and automatically the system will be calibrate everything.
Yeah, for the that's good. I think I'm understanding the question better now. So for calibration, the amount of that you see through your phone is actually not significant for that, because it's really just trying to measure, like, this is 10 feet. You're telling your phone, whatever, this is X number of feet, so that it can then gauge. Where that becomes more important is when you're actually doing, or more impactful when you're actually doing the point scans. That, like I said, your phone is actually seeing quite a bit more than you're seeing in your screen. So that's one thing to realize, is you're capturing more than you see. But also when you do multiple passages or whatever, obviously when you're further, just like your own vision, when you're further away from an object, you can see more in your field of view, and you're actually capturing any given surface or scene multiple times. And so each time you're moving away to get another passage, you're actually capturing more, say more height. It mostly impacts height, I would say. That was the mistake I made initially, was I was like, for a skyscraper, I was kind of thinking like, oh, I need to like scan low, and then I need to come back and do a high pass. And you really don't need to do that, because as you do your passages further away, it will automatically be captured in the field of view.
Thank you.
Yes, the minimum distance could be 2-3 meters from the users to the building facade.
Okay, I do not see any other questions. So thank you very much, everyone. And we'll see everyone tomorrow, same time, for the OpenAI Cloud workshop.
Thank you. Thank you. Bye-bye.